Hey guys, it's Vince. Today in this video we're going to be discussing a video that was sent to me. I get these videos all the time from potential clients, past clients, who will try to show me what's happening with their system. And I'll get a message similar to, hey Vince, I'm hoping you can help me with such and such problem. Here's a quick video. And when I say quick, this is a literal 7-second video. Okay? This is beyond quick. Okay, and you'll see exactly what this motor is doing. Let's start it. Now, I'm immediately asked, what could this be? And I really wish I had the skill set that in 7 seconds I could tell you what's wrong with this system. Okay, there's no way I can do that, guys. I get videos like this once again all the time. And the thing I always tell my potential clients or clients is that if I do receive a video like this, and I've used this analogy in the past, think of me as a mechanic being asked to diagnose a car without the car in front of me. Okay? My hurdles are that I have possibly, thousands of variables, and I don't have any of that equipment in front of me to review, to go over. But I can tell you this. Over years of doing this, listening to the motor, I can already tell you, like many of you already know, it's associated with the motor in some respect. It's going to either be in the gearing, is what we see here, because this is a rack and pinion. We can see the rack over here. But when I see details, and guys always like, man, your details are crazy. The reason my details are crazy is because mainly I'm studying the internet all the time. I'm studying the internet pictures and videos I get, because that's usually all I have to go by. I'm not flying around the country or the world dealing with people. So the more information I get from videos, or I should say the lack of, I have to become sort of a detective in what I'm seeing. And many of you already look at this video, and you see here we've got a gear or rack and pinion system. And when we look at this, we can see that this gear is absolutely filthy. Okay, and of course this potential client told me that this system was built by someone else. He went back and revamped the system. But I can tell you right now, I always look for things like this. If I see that the gearing or the transmission of a system is filthy, surface rust, whatever it may be, the first area of concern is this. The machine should be cleaned. And when I say cleaned, it's one thing if you have lubrication in a certain area. When we start seeing debris and black grease everywhere, you already know you're asking for trouble, because that grease over time is going to attract more dirt. If it's not the properly used grease, which most guys are not using, a graphite film, they're using regular grease, and over time, sawdust, different types of debris from different substrates is going to affect your tolerances, especially your gear engagement on your rack. Okay, rack and pinion for a CNC router, first of all, is not the most optimal transmission for numerous reasons. Mainly being, we have way too many moving parts, whereas a ball screw transmission is direct drive, you have a transmission here. Okay, we have a pulley system here that's similar to what you see on a 3D printer. We have a belt here similar to what you see on your idler pulley on your vehicle. Overall, it's a very simple transmission, and that's why a lot of companies use it, especially in the past, Gerbers and whatnot. They all use these type of transmissions because it's simple and it's cheap. Larger ROI for the company, okay? Ball screw transmission, simpler in the sense of servicing for the end user, way more precise, and again, much easier to deal with. You have way more moving parts here. So this potential client would have to tear down, take the belt off, remove the motor, go through everything. And what I get asked the most is, like I said, I'll get this video and then I get told, do you have any ideas, suggestions? Well, the suggestion I would do first is you'd want to unmount the motor from the chassis. Once the motor is unmounted from the chassis, do you notice it performing the same way? Okay, so before I go into detail, I would tell the client, grab a pen and paper. I want you to start documenting your T&E, standing for trial and error. If you're not familiar with trial and error, guys, in CNC genre, you will be in for a rude, expensive awakening. Why I say that is this. If you're going to pay someone, myself or anyone else, to do trial and error on your system, it's not going to be cheap because it takes a lot of time. So if you're an individual that has, if you're time rich, money poor, invest your time. If you have more money available because you're a business owner and you realize that, hey, their time is just as valuable as mine, you're going to pay someone because they can streamline the entire process. You have more resources available. This is simple logic, but sometimes it's massively overlooked. Because again, if you contact me, I'm just letting you know my time is the most precious thing I have as a one-man company. So in order to assist you properly, I have to stop everything. I do a remote actual consultation using Microsoft Teams. I expect to have a high definition camera present, a very good microphone so we can speak to each other, and then I'm basically there with you in a digital format. That allows me, once again, to remove the email and all this back and forth crap so we can dial in what's actually going on with the system, because a 7-second video just isn't doing me justice. So keep that in mind in what I just said. Grab your pen and paper. Either if you're going to contact me for a consultation, we would do that anyways. I would say get a pen and paper. You're going to document everything so you learn. That's the whole principle behind T&E, is that you learn. You shouldn't be having to call someone for tech support for a similar issue if you're doing it properly, so you're actually learning. That's the whole goal here. So once again, when you have your pen and paper, you remove the motor from the chassis. You then operate the motor to see if you have the problem resolved. If the motor is removed, the pulley's unloaded, is the motor still acting funny? If it is, okay. Now we write down why we are going to move to the next step. I tried unmounting the motor is still acting jittery. My next step is going to be taking the accessories off of another axis and trying it. Meaning, I'm going to use a motor, the motor's cable, and the motor's connector on this axis, on the drive, whatever drive you're using, and you're going to attempt to use the motor. You're going to write this down. Once you've written that down, the next step is going to be documenting what effect it had. Did it change? Did you notice a change? Did it do anything? If it didn't make a change, we go to the next step. We start breaking it down. Now, usually what ends up happening is that aha moment where you change a component and all of a sudden, like magic, the chassis becomes, or I should say the motor becomes normal in its rhythm. Everything seems right. We're moving again, no problems. Then what we want to do is isolate it even further. Is it the cable? Is it just the cable itself? Is it the connector? Is it just the connector itself? I mean, we got to go down the whole rabbit hole to see what is the part. And once we identify that specific component that needs to be replaced, we then replace it. Okay? Now, I'm going to say this. With a transmission that's in this shape, and many of you out there looking at this, when I see something dirty and filthy like this, the immediate response in my brain is the rest of the chassis is in the same condition, because the odds of this client or potential client going through and cleaning everything but this actual axis logically doesn't make sense, right? I mean, logically it just doesn't make sense. If your car is filthy on the outside, what's the odds of it's immaculate on the inside? Think about that, logically. You know, I mean, we have to look at logic when we look at these systems, and a lot of times the answers are there if you learn how to listen to the equipment. The equipment's talking to you. The document process is so that you can gravitate towards learning what she's telling you. And that's the thing. You want to become the CNC whisperer, and the only way to become the CNC whisperer is to literally become really adept at trial and error of what you're specifically looking at. I have clients that know their machine so well they can hear when a bearing is out with the stepper going at full rapids. They'll know right away, hey, I know I need to replace this. This is it. I did a PM on the system, 8 hours ago. I've just cut, I don't even know how many projects. I'm running 100 IPM. I'm using this flute end mill. It goes right down the line. And they're that good because they've worked with their equipment that long. That's what you all should have that goal set in mind. I know I do, because why would I want to work inefficiently? The robot's doing the work. All you have to do is listen to it. That's it. When we hire a worker, we have to listen to all kinds of problems, excuses, this, that, the other one's stealing from you. You don't know what's going on. You hire a robot, all you have to do is listen to it. It just wants someone there to listen to. So your objective is observation and listening. And if you can do those two things really well, you never have problems. First of all, you want to set up in Mach 3, and I'm going to put a link in this video's description of how to go about looking at a preventative maintenance schedule. And what I mean by a preventative maintenance schedule for my new guys is a schedule at which you can look at how many hours you have on the machine. I've asked many guys who send me videos like this, when was the last time you did a preventative maintenance on the machine? And they're like, well, I don't know, or, oh, I do it every day. Well, we know that if he said to me he did this every day, or I do it every 10 hours, I could tell you, looking at a gear like this, that just wouldn't be logical. So, again, that's why I ask these questions. If a guy is maintaining his equipment and acting in a proactive fashion, you're not going to encounter problems like this usually because it won't sneak up on you. You'll already catch it before it becomes a big problem. And the big problem we all know is when the axis gives you trouble when the robot is cutting a project for a client that has a deadline. That's usually when guys are like, oh my God, Vin, I don't know what to do. You don't want to be that guy. You want to be the guy who figures out, hey, I've run the machine 10 hours. I'm going to go over her. I'm going to spend an hour, 2 hours today, go over the whole system, make sure she's golden, and then I can take more work and I have peace of mind. That is what you want to do. And I'm telling you right now, those hours spent doing the PMs, they will shrink. And why I say they will shrink is your experience will grow. You'll learn your equipment more. You'll know that from that 10-hour period, you're going to see a tremendous difference in the cleanliness of the machine. Okay, you go over lubrication, document everything. Document it all. Mock will track the hours, and then you document what was done. If an axis starts acting funny again, like any repairs on this axis, I would document. I would document because, first of all, full-scale factories document everything that's been done on every piece of equipment. Why? So they always have a record. If you mimic success, you have no choice but to be successful. If they're successful at their level, why wouldn't you be? Right? Don't reinvent the wheel. Copy what you know works. And do that, and you'll always have something to go back on. If that axis ever acts funny again, hey, I changed the bearing on this state for this axis. I went through and I changed this thrust bearing. Okay. And you notice you're having that same problem with that axis. First of all, you can contact the vendor and say, hey, I changed this bearing. Remember me? I'm da-da-da-da-da. You can go down a whole line of what was done. Give yourself a point of reference. Make it to where you guys are working this equipment more precise. It'll make you more efficient at your business. It'll make you spend less overall on the robot, and you become twice as productive. And that's why I make videos like this. Because guys say, when they say to me, wow, I didn't realize a consultation is that expensive. And I explained why it's so expensive. But if you learn something from it, is it that expensive? If it saves you time with your business, is it that expensive? So think about it. 7-second video is not doing me justice. It's certainly not going to do you justice. But a couple hours going over this machine, cleaning everything, going through the process of what I just said to isolate this axis, you'll certainly find it. Again, isolating a drive from a motor, very simple to do. Once again, we change the accessories connected to the drive. First, we validate the drive is good by changing the motor itself with another motor from another verified axis that's working. 99.9% of you will always have a motor available from a previous axis that is working fine, and then you're good. And that's the whole key, is going through and learning that process. Document it, document it, document it. Become scientific and precise. And the more precision you guys execute, the less confrontation you'll have with the machine, and you'll find it's a much smoother process. So again, I hope that this video has been helpful. If you guys have any comments that I forgot as far as diagnosing the axis, I'd love to hear them in the comments, because again, I'm human. I don't remember everything. Once again, we have 7 seconds here, guys. So whatever you saw, I saw, and hopefully many of you can go through and figure out exactly what's going on. Once again, to me, I don't know what's actually happening. I wish I could diagnose in 7 seconds, but I can't. I'm not at that level yet. But one thing I do know is I would definitely unmount that motor and validate that the motor itself is okay as far as motion. If it's not, once again, I go through that process of trial and error. The other area I would highly recommend for any of you guys working with rack and pinion systems is, first of all, these gears should be immaculate all the time. The gears on the rack should be immaculate all the time. I cannot tell you how many service calls I've done where I've shown up, and even local service calls where I've shown up, and I live in Florida. And in Florida, our humidity is just ungodly. Okay, and I'll see a guy with his shop door open, and there's no climate-controlled environment. And the rack is a steel rack, so of course surface rust forms in probably 2 or 3 hours. You start getting a film, and over months and weeks of time it grows thicker and thicker, and your tolerance gets worse. And I will never understand why people do not actually climate control their environment for the robots. I see it on YouTube. It's very seldom done. If you guys are serious about this genre, do yourself a favor. Don't buy a robot unless you have a climate controlled environment. First of all, you'll work neater. You'll feel better about what you're doing, and your equipment will thank you. You're not going to beat it up. Steel gears do not like humidity. Electronics do not like humidity. Your longevity of this equipment is based upon how well you take care of it. And I thank God every day that my dad taught me taking care of what you have guarantees you your investment will take care of you. And I hope many of you do that because it's easy to have you, especially as a vendor, be like, hey, you need to buy this. Buying stuff and replacing stuff is useless if you're putting it back in the same environment that the stuff that basically had no longevity came from. So think about it in those terms and really, really pay attention. Once again, my guys using rack and pinion to all these moving parts. We have a pulley system here. We don't know how the actual teeth are on here. We don't know how the tension is on this belt. You got to go through the rack once again, double check, make sure there's no surface rust forming. The tolerance on the rack is good. The bolts are right. There's no vibration issues. Has the system been assembled with Loctite as it should? That's another point I've never really brought up. I find it to be a moot point, but again, bringing it up for my new guys, when you build a robot, every bolt should have Loctite on it. If it's not an actual locking nut, where it has a nylon actual gasket in the nut that seals it, you want to make sure every bolt has Loctite. That is best practice, because if it doesn't, it's not uncommon at all to have all them series of vibrations for hours and hours and hours beating up your machine. Bolts come loose, and I've seen it endlessly. So again, these are things to think about. Invest yourself in that pad, and I hope you will use it after watching many of my videos. I hope that's overall what we're doing. We're taking notes. We're trying to learn. I want to make you guys as sharp as possible because it's just going to make you more money. I mean, it makes us all more money. At least then when you buy components from me, you realize, hey, they're going to last. They're going to last even longer because I'm getting more equipped at what I'm doing, and that is the overall goal. So again, I hope that this video has been helpful to all of my subs. I love you guys. The channel's growing crazily, and I'm doing my best right now to keep up with it. And of course, to shop. If you do have any questions, require consultations, any quote ideas, please message me direct at storm2313@gmail.com. You can also message me through my eBay story. You'll see links in the beginning of the video and at the end. I thank you all. Take care.